Hello, my fellow YouTubers. This is Roy back again. Here we're working on the Clemente Figueroa patent, and it's a set of coils. The way I have this hooked up right now is I just basically discharged it, and the way to discharge it, stop it from working, is basically like any other wave. You just shunt it, and the wave kills the wave out, shunts the wave. Funny thing is though, the voltmeter is hooked up coming from the pickup coils. Now the center row of coils are pickup coils, so visualize this. So these group of magnets are making a magnetic field in the center here. And I have the field moving in different high pressure and low pressure. So it has a high pressure of a sine wave and a low pressure of a sine wave, and it's continuing back and forth. I'm using it by beating down on the transistor through my group of resistant wires up there, where everything's connected through there, and that transistor's banging that. So I just shunted it out, and you can see on the voltmeter is 0.25 volts. All right, I got it on volts, DC volts, DC volts. All right, this is mind-blowing. So I decided to I got each end of the pickup coils going to a full wave bridge rectifier, which is right there, okay? And going into the AC side, one side out to the AC, the other side out to the AC. Then coming out of the DC, I am going into these capacitors, okay? And I have earth ground right here. So this wire here is earth ground coming out, and it's just stuck right there. And it goes down to the table and to a piece of rebar I got in between the cracks of the concrete. So this is, you guys ready for this? This is crazy. So the system's not really working right now, but stuff is showing up on there. Could it be the capacitors have point? Probably, okay? And this is what's fascinating. Let's go ahead and let's take this LED, and what we're going to do is a full wave bridge rectifier germanium diodes, okay? And LED in the middle. And we're gonna go ahead and connect. Now it only works on the second and third, I'm gonna call it harmonics in. Watch the voltmeter, okay? And that was my finger on there bringing that up. So the light's on. Okay, we have 1.30 volts, okay? We put a load on it, and we just pulled it up from what, 0.25 of a volt, and we just brought it up, we put a load on it. Now what happens if we had capacitors in between ground, earth ground? What do you think will happen? Leave your comments. So I'm going to go ahead and connect earth ground. The light lit up. Wait, hold on, look. First of all, look how the light's lit right now. Okay? You see that? It's lit, but it's not bright. Now I'm going to connect earth ground. The light is super light. And look at the volts. That's 13.02 volts. And watch the volts keep climbing. Let's watch the volts. Now we got a load on this. I didn't even have the system charged. Earth ground coming up through capacitor A, coming through capacitor A into capacitor B, or coming through, basically no, we're coming through ground into one plate, out of the other plate, we're coming up and going to the full wave bridge rectifier, okay? That's that green wire. On the negative side of the DC. And then coming out of the positive side of the DC, we have it running to the other leg on the capacitor. So here's the light still on, and we're still climbing volts over here. Explain that to me, guys. This is pretty amazing that now I'm pulling voltage from the ground and I'm charging up these capacitors are charging. Nothing, I'm not doing anything to these coils. I got a light lighting up, free energy, and I have two capacitors charging. And there's our charging numbers. There's our light lighting up. Now let's go ahead and show you something. I'm going to disconnect the light. Okay? Watch the voltmeter. Voltmeter down. Now remember, the voltmeter is not connected to the capacitors, so that charge is still in these capacitors. The voltmeter is connected to the full wave bridge rectifier. So let's go ahead and connect back the ground to the light. Light's back on, and we're back up to the 13 volts and climbing. All right, guys, I'm running low on power. Leave your comments. Now, one thing I want to talk about is with Ed Lee Scallon. He had coils like this all over his walls, and I'm digging deep because who needs power coming into your facility, which is one thing Ed never did have. He never had power coming in, okay? He had something making power. And I don't believe it's so much the wheel. I believe the wheel was more for the carving, the electrostatic impulses that he's putting into the coral rocks to make them lighter. And I believe he figured out how to do that by running you can see through the video he's running an iron core through the blocks, and you can see the chains coming down and wrapping around the bottom of the block, and the chain comes up to each side of the core. So what you have is an iron core going through the coral rock, and then you have a chain wrapping around the bottom. Then he has two cables coming down from the upper black box, and I believe that is getting a signal from the wheelbase, which is separating the ions that are in the coral itself, but to the iron that's going through it. So basically what he could be doing is causing a separation, a divergence in the coral itself, because the coral itself would have its own separation of positive and negative molecules and improperly placed. But if you were to offset that placement, you could go ahead and unbalance the rock, and I believe that's what he was doing. And I believe technology like this, because this is 1908 patent, and I believe once Ed got a hold of it in right after that, he was all over doing what he was doing with the rocks. So I believe this is a way of taking the first spark, starting it through a system, sort of like taking a shock wave and sending it to where it comes back and it teeters back and forth, just like a vibration in an open space would do. So guys, leave your comments. Hopefully you enjoy the work. I have some other things to show you. Building a oscillator tank circuit that goes along with this, so we could stick with a frequency so we can control its strength. Because I have seen that when I use the signal generator, when I change the frequencies and the type of wave, I I can see a difference in strength. So now I figured out which frequencies are the ones that we need. And right now, you're starting the system, and the system is started. Okay, look at us. We're still climbing. 14.505 volts. It's because I got this load on here, guys. Okay, and now watch. I'll disconnect it. The volts drop back down. We're not reading the volts from the canisters. Let's go ahead and connect this again. Lights back on. Lights back on. And look at the voltmeter. Back to what I was saying. So basically, the key element that everybody see, Clemente did not give out all the information in the patents, and this is why most of all people are struggling to figure out exactly does it work and how does it work and what amplifies it. And so far, what I've seen out there, and I gotta say, guys, I'm glad we're like a team out there. But first time I ever went out there, thanks to my buddy Exhibits, turned me on to a open org site for Mr. Clemente, and it's good to be part of a team. I haven't introduced myself over there. In fact, I haven't shown anybody my videos because I haven't watched any of theirs. And basically, now that I see that I'm very advanced in this technology, we can bring this into today's date, and this stuff is like having a car battery, and it's constantly charging. There's no light here. There's nothing going on. We're up to 14.2 and change volts, climbing into capacitors. Going back to the setup, it's the resonance, of the coils that you build, and that dictates the frequency. So you need to know what frequency to bang the coils in, so you can have the coils in resonance. And once you get the resonance built up in the system by running through a half a cycle, then you see the back EMF of the back end of the cycle creates one period, and when one period has passed, that the whole system is starting over again, because it just started, went to its high pressure, and then it went backwards to the lowest pressure. And I don't think that people understand that in looking at any of the conversations that people are talking about on the open org of Clemente Figueroa. So I don't believe he told the truth on everything, and I don't believe everything is in there. And I have a lot more to talk about, especially with the LCR circuit, the tank circuit that's going to be attached to this, which will be a frequency driver. And once that frequency driver is in place, I know how to get these super excited and how to amplify this power that's coming in. So you guys leave your comments. Hopefully you enjoy. Peace out, my brothers. Peace out.